Hello. Yeah, it's Rajan. I'm online. Okay.
Hello.
Hello.
Yes, sir, I can.
Yeah, can you hear me?
Yes, sir.
Okay. So can you bring that mic closer so that I can hear properly?
Hello.
Hello.
Yes, sir, I can hear now.
Okay. So like yesterday we did about that rational numbers, right? You
Yes.
remember?
Yes.
The numbers which can be represented in the form P by Q, where P and Q are the integers, right?
Yes.
Now the next here is irrational numbers. Do you know anything about irrational numbers?
No, sir.
Rational numbers, you know?
Yes.
Yeah, rational numbers means the numbers which we can represent in the form P by Q. The numbers that can be represented in the form P by Q. Those are the rational numbers. And if we are not able to represent it in the form P by Q, that is, we cannot represent a number in as a ratio of two integers, then it is known as irrational number, right? And one like the major difference is whenever we have the decimal representation of a number. Decimal representation, you know, if we represent a number in the decimal form, like 2.5, 2.9, 2.5255252, or say 2.56, like that. These are the decimal representation of the numbers. So whenever we have a decimal representation of numbers, there can be three cases. Can you tell me what are the three cases that we can have?
Sir, I don't know.
The three cases, like whenever we have a decimal representation of the numbers, then we can have the three cases. Number one, terminating. Number two, non-terminating but recurring. And number three, non-terminating, terminating, and non-recurring. Have you done this thing before?
No, sir.
Have you heard of these words, terminating decimal number, non-terminating, or say non-terminating recurring, or non-terminating non-recurring? Hello.
Hello. Yes, I can hear.
Okay, yeah, but I cannot hear you. Can you bring that mic
The mic
closer?
close. Hello.
Yeah. So what I was asking is like, have you done this thing before, or have you heard of these terms: terminating decimal,
No, sir.
non-terminating but recurring, and non-terminating and non-recurring decimals?
No,
Hmm?
I didn't hear.
Okay, you haven't done. Okay. Now let's start from this point. What are these things? What are these terminating decimals, non-terminating, recurring, and non-recurring? Right? Now say if I write 7 divided by 2, what will be the decimal representation of 7 divided by 2? Can you evaluate this? 7 divided by 2?
Sir, 3.5.
3.5 you are getting. Okay. Take another number. Say take a number 3 by 5. What number you are getting? 3 by 5. Did you
Sir,
get the answer? Hmm?
1.66. 1.666 I'm getting.
1.6 or 0.6. If you divide 3 by 5, because 3 is less than 5, so we'll put 0 in decimal point and 0, and 6 times 30. So what is 3 by 5? It is 0.6. Try one more. Say if I write uh, 11 by 25, or say let it be 12 by 25. 12 divided by 25. How much you got?
Sir, I'm still doing.
Okay, you are doing.
Sir, it's coming 2.08.
12 divided by 25. So what you get? 12, 25 here. Now 12 is less than 25. Point 0 comes 4 times, 8 times. So how much we are getting? 0.48. That is 12 by 25. Did you get this one? Right? 0.48. Clear?
Yes.
Now, okay, try one more. Suppose if I write, say, let it be 16, or I'll take something else. I'll take, okay, 17. 17 divided by 50. What you're getting? 17 divided by 50.
Sir, 0.34.
Got the answer?
Yeah, 0.34.
0.34. 0.34, correct? So this is 0.34. Now, did you notice anything here? Here we got 3.5. Here we got 0.6. Here we got 0.48. Here we got 0.34. So I think you might have noticed in all these divisions, say in this case, after one decimal place, we got remainder 0. Here, after one decimal place, we got remainder 0. Here, after two decimal places, we got remainder 0. And here also, after two decimal places, we got remainder 0. Did you notice that?
Yes, sir.
So all these types of rational numbers where, or all these types of fractional numbers which when represented in terms of decimals always terminates. It terminated after one decimal, it terminated after one decimal, it terminated after two decimals, it terminated after two decimals. So such type of numbers are known as terminating decimal numbers. Did you understand this? Hello?
Yes, sir.
Yeah, so the numbers which terminates after a certain number of decimal places are known as terminating decimal numbers. So that's the first case. Now the second, take one example, try this one, what you get, 10 divided by 3. What will get 10 divided by 3 in terms of decimals?
So it's coming 3.3333.
3.3333.
3333.
Right, it's not terminating. It's will go on. We'll never get the remainder 0. So this we are getting 3.3333 and so on. So in this division, like if we try to divide 10 by 3, we always get a remainder 1. And if we continue dividing again and again and again and again, we'll never get a remainder 0. How long we perform the division? We'll perform the division for 1 hour, 2 hour, 1 day, 1 month, 1 year. Continuously, if we go on dividing, we'll never get a remainder 0, right? So this type of number, okay, take one more number, try one more number. 13 divided by 6. Try this one. We'll try one or two more.
So it's coming 2.1666.
It's coming
1666.
13, 2, 12, 1.01, and then 6, then 4, 0, 6 times 36, then we'll get 4, again we'll put 0, so this will get 2.166666 and so on up to infinity. Clear?
Yes.
So in both the cases, we see that if we continue dividing again and again and again, we'll never get the remainder 0. We'll never get the remainder 0. How long we perform the division? We perform the division for 1 hour, 2 hour, 1 day. Even if we perform for 1 year, 2 year, it will go on continue the same pattern. It will go. So such type of numbers are known as non-terminating but repeating. But because it is repeating, it is repeating. And for the word repeat, we use one more word. It is called recurring. It is also called recurring. Either we use the word repeating, either we use the word repeating, or we use the word recurring. So this is the second type of the fractional number, the decimal representation of the fractional number. That is, it is non-terminating but repeating. The previous one was a terminating. It was terminating after certain places of decimal. Okay. Now take one more example. Say we'll take the square root of 2. You know how to find the square root?
So 2 I don't know how to find. Like the normal ones I know, like 4, 8, like
no, the division method. The division method. I think you might have done in 8th standard to find the square root of a number. If we want to find the square root of this number, that is 2, so what we do? We'll start from 1. We'll start from 1. 1 into 1 is equal to 1. Then 2 into 2 is equal to 4. 4 is greater, so we'll take 1. So 1 is 1. And then 2 minus 1 is 1. Right? And this 1 plus 1 is equal to 2. Clear?
No, the board is very blur, I can't see.
Hello? Can you hear me?
Very blur, I can't see.
Okay, the board is not. Can you see it now? Is it clear now?
Yes, sir.
Yeah. Now we got 1 over here, so we'll put a decimal place here and then 2 zeros. Then we do the division when we are dividing two numbers, and after the decimal point we put only 1 0. Whereas in case of square root, when we are finding the square root of a number, then if we put decimal point, we put 2 zeros. So 2 zeros. Now next 4, 4, 4. So 4, 4, 16, 4, 2, 8, 9, and this becomes 28. This becomes 4, and the decimal point is there, again 2 zeros. So like this, if we go on.
The second step I didn't understand.
Sorry?
The second step I didn't understand.
No, no, do you know how to find the square root of a number?
So 2 I don't know. Rest all I know. Like small numbers I don't know. Long division method I know.
Long division method you haven't done?
No, I did. But I
So
don't know
then,
2 digits.
no. So how you do this one? So today what you do after finishing the class, just try these things, how to find the square root of a number, right?
Yes, sir.
Okay, first we'll do how to find the square root of a number. Say 1, 2, 2, 5. I want to find the square root of this number. So what we do, the first step is we always make pairs starting from the right hand side. We make pairs starting from the right hand side. This is one, this is second. Is it clear?
Yes, sir.
Now we'll take the first pair. The first pair is 12. The first pair is 12. Now we'll start from 1. 1 into 1 is 1. 1 is less than 12. So we'll move on to 2. 2 into 2 is equal to 4. 4 is less than 12. We'll move on to 3. 3 into 3 is 9. 9 is less than 12. So we'll move on to 4. 4 into 4 is 16.
3.
But 16 is greater than 12, so we'll consider 3. Is this clear till here? Right? So the first pair is 12. We consider this number. Now we will start from 1. 1 times 1 is 1. 2, 4, 3, 9. 4, 4 is 16. But 16 is greater than 12. So we'll stop over here. So 3. We'll write 3 here. We'll write 3 here. And then 3, 3 is 9. And like we subtract in ordinary division, so here also we subtract 12 minus 3 is 12 minus 9 is 3. And then in case of normal division, we bring down one number at a time. But in square root, we bring down two numbers at a time. So this 2 I will come over here. Now this 3 again will write once more and add these two. 3 plus 3 is 6. Is it clear till here?
Yes.
Now the same process will repeat like we did for the first step. Now the number is 325. This. And here the number is 6. So first we'll start with 1. 61 into 1 is 61. This is less than 325. We'll move on to the next number, so it becomes 62 into 2. 2, 2 is 4, 2, 6 is 12. 124 is less than this. We'll move on to the next number. 63 into 3. 3, 3 is 9, 3, 6 is 18. This is less. 189 is less than 325, so we'll move on to the next number. 4, 4 is 16. 1, 4, 6, 24, 256. 256 is less than this. We'll move on to the next number. 5, 5 is 25. 2, 5, 6 is 32. So 320. We've got this. So it means 5 here, 5 here, 5 here. So 5, 5 is 25. 2, 3. Remainder we are getting 0. So therefore the square root of 1225 is equal to 35. Can you do one problem now?
Yes, sir.
Right, I'll give one problem. Find the square root of 2025. Find the square root of 2025. 2025.
45.
Okay, 45 you got, 4, 5. Okay, correct. Try one more. Okay, instead of 576, you take 676. Make it 676. Got it?
No, sir, I'm still doing. Sir, 26.
Hmm?
26.
Yeah, 26, right. So till now, I've given the square root of the numbers which are perfectly divisible. Now I'll give a few examples like where we need to put the decimals and all. Suppose if I take a number, say 150. I want to find the square root of this number. So here also we'll follow the same steps. We'll make the pairs starting from the right. Two numbers, one pair, and only one number is left over here. Again, the same procedure. The number is 1. So we'll start with 1. 1 into 1 is equal to 1. So 1, 1, 1. And here 1. So we'll get 2. This becomes 0. And then we'll bring down 5, 0. Because in case of square roots, we always bring down two numbers at a time. Clear? Now we have a number 50 over here and 2 over here. So again the same procedure. The number is 50. So 21 into 1 is 21 is less than this. 2 into 2 is equal to 44 less than this. 23 multiplied by 3 is equal to 339, 326. So it's greater. We'll take this one. So this becomes 12. Here 2. And here 2. 2, 2 is 4. So this becomes 44. And this becomes 24. The remainder is 6. So in the previous problems that you have done, we got the remainder 0 over here because they were all the perfect squares, right? Those numbers were the perfect square numbers, so that's why we got 0 over here. But here we didn't get 0. We have the 6, and here we are finished with all the numbers. So whenever all the numbers over here are finished and still here the number is left, we follow the same procedure like we do with the decimal numbers. With the division, we'll put a decimal point. We'll put a decimal point over here, and like in case of division, whenever we put a decimal point, we put 1 0 over here. But in case of a square root, we always put 2 zeros. So here decimal point, and then we'll put 2 zeros. We'll put 2 zeros. Now we have 600 over here, and here it is 2
So in all
4.
the questions we have to put 2 zeros in the
So, sorry.
in all the
Hello.
we have to put 2 zeros in the question, like
Hmm.
the remainder in the remainder.
The remainder here we got 6.
Always we have to put 2 zeros.
No, always.
We have to put 2 zeros.
We have to put 2 zeros always. That's what I was telling. In case of division, we always put 1 0. In case of square root, we always put 2 zeros, right? So whenever we put a decimal point, we put 2 zeros. In case of division, we put 1 0, right? So 2 zeros over here, 600 we got, and here it is 24. So again, the same steps, 241 multiplied by 1 is equal to 241. Now this 241 is less than 600, so we'll take 242 multiplied with 2. 2 is 4, 2 4 is 8, 2 2 is 4, so 484. Again, 243 multiplied with 3 is equal to 3, 3 is 9, 3 4 is 12, 1, 3 2 6 7. So this number is greater than 600, so we'll take this number. So we get 2 over here, 2 here, 2 here. So here we get 4, 8, 4, and here we get 2, 4, 4, and then subtract. 6 minus 4, 10 minus 4 is 6, and 9 minus 8 is 1, 116. Is it clear? This is step
Yes.
clear?
Yes.
Now still, yeah, now still the remainder is not 0. So what we'll do, decimal point is already there. We'll put 2 more zeros. We'll put 2 more zeros. After putting these 2 more zeros, again the same procedure will apply. We'll start with 244. We'll start with 2441. Multiplied by 1 is 2441. Less than this. 2442 multiplied with 2 is equal to 4884. It's less than this. 2443 multiplied with 3 is equal to 339. 3 4 is 12, 12 is 13, 3 2 6 7. Less than this. 2444 multiplied with 4, 4 4 is 16, 17, and then again 17, 9. Less than this. 2 4 4 5 multiplied with 5, 5 5 is 25. 2 5 4 is 22, 5 4 is 22, 5 2 12. So this one is greater than this, so we'll stop over here. So we'll put 4 here, 4 here, 4, and the number is 9775. So like this, we go on, continue dividing it. Clear? Now try this one to find the square root of 2. The point where we left. Actually, the question was to find the square root of 2. Try this one.
So here I'm getting like this 0.
Hmm.
0 and
How much you got for square root of 2?
no, like this I'm getting.
Sorry, I couldn't hear.
Sir, I'm showing the book.
You are? Okay. Correct. So how much you
Like this.
got? Okay. 1 times. No, it's not coming clearly. Can you what you? No, no, it's is it your video is on?
Yes, sir.
Yeah, now it is coming. Now again it gone. It's not coming. I think that yeah, now it came. Again went. Yeah, now it has come. Again it went.
Sir, I'll disconnect and call again.
Yeah, it's not coming. It's going off.
Sir, I'll disconnect and call again.
It will come like this. The square root of 2, we want to find 1 times 1, 1. So 1. I think till here you got.
Yes.
Right?
Yes.
Now we see this number is greater than this number. Clear? This number is greater than this number. So in case of division also we do the same thing. Whenever this number is greater than this number, what we do, we put the decimal point over here. We put the decimal point, and in case of division, whenever we put a decimal point, we put 1 0 over here. But in case of square root, whenever we put a decimal point, we always put 2 zeros over here. Now here it is 2 and here it is 100. So it is 100 and 2. So again 21 multiplied by 1 is 21. It's less than 100. 22 multiplied by 2 is equal to 44. Less than 100. 23 multiplied by 3 is equal to how much? 69. Less than 100. 24 multiplied by 4 is equal to 96. Less than 100. 25 multiplied by 5 is equal to 125. 125 is greater than 100, so we'll consider this one. This is 4, 4, 4, and here we get 96. Remainder again 4, and this we add, we get 8. Can you continue?
Yes.
Next step. So 4 we got, decimal point we have. So 2 zeros will put over here. What will be the next step?
Sir, I'm getting remainder as 119.
Hmm?
Remainder I'm getting
What
as
you have to?
119.
No, what you got next?
Next I got 119 as remainder.
119. How you got 119? One, if you, yeah, this is 28, this is 400. 400, 28, 1 into 1 is 281. Then 2 will take 282 into 2. This is 4, this 6, and it's greater. So we'll take this one. 1, 1, 1, 282, and here 281. 10 minus 1 is 9, 9 minus 8 is 1, and then 1, and decimal is there. We again put 2 more zeros. What will come next?
So that's what I got as remainder 119.
Ah, okay, yeah. After that, what? After that,
So after that I have to.
so after that here, if you do, you'll get 4. After that, you'll get 2, and it will go on continue. It will never end. It will never end. So that's why this also is an example of non-terminating and non-repeating, non-terminating and non-repeating. Clear?
Yes, sir.
So basically, the fractional numbers, we have the and we want to represent it in the decimal form, we get either of these three. Either we get the terminating decimal number, or we get non-terminating but repeating decimal number, or we get non-terminating and non-repeating decimal numbers, right?
Yes.
Clear?
Yes, sir.
Now, tomorrow we'll continue with this. We'll take what exactly are the irrational numbers from
So
this point,
tomorrow I
because
won't be there.
sorry.
Tomorrow I won't be there.
Okay, tomorrow Saturday.
Saturday is okay.
Saturday can we have?
Yeah.
Okay. Why I don't want to move further, because first you practice this to find the square root,
Yes.
right? So without that we'll not be able to do next in this chapter. That's why first practice how to find the square roots, then we'll move. So tomorrow practice, evening you practice all these things, then day after tomorrow Saturday will continue, right?
So Saturday what time?
Saturday we can have it around the same time, around or I'll tell you, I'll just send the message whenever I'll be free, I'll let you know, right?
Yes, sir.
Okay.